So ito na. Yung good morning everyone. My name is Pierre Tecson. So we will talk about test benches in HDL. So I'll let Lance Sombillo start po. So Lance.
Ano po ba ako?
Yes, you can start now.
So, hello everyone. My name is Andrei sa Sombillo. Yung topic na naka-assign sa akin is generating manual stimulus in test benches. But before we begin, I would like to share to you my understanding what a test bench is. A test bench is a simulator or another module which allows you to verify functionality of your hardware design or the design under test, which is or DUT for short, before it is implemented in actual hardware. It is also a way to input specific data for your design and check what that the correct outputs are produced. Dito papasok yung generating stimulus manually. Um, in hardware description language or HDL test benches, generating manual stimulus refers to the process of creating and applying input stimuli to the design under test or DUT for short. Using manual methods, these values are applied to the inputs of the DUT at a specific simulation times to observe its behavior. In this context, generating a stimulus manually involves developing and controlling input signals to the DUT by specifying the values for certain signals in the specific simulating time. Then, this can be done using HDL code within the test bench. The purpose on generating it is because generating a stimulus manual is to ensure that the DUT that has been created in the design module responds correctly to different input scenarios or cases and produces the expected output that the designer or developer intended to have. The reason bakit ito nare-recommend is that it gives you full control and understanding on what is happening to your design. B, it is easier to debug when issue arise. Most designers will be able to tell where the issues are through observation. C, it is useful for testing corner cases and edge scenarios that may not be covered by automated stimulus generation. And D, manually specifying stimulus can be more efficient than relying on complex automated stimulus generation methods. So, gumawa po ako ng equation on paano ba natin ma-apply yung stimulus manually sa test bench mismo. So, gumawa ako ng equation. Papakita ko sa inyo yung video.
Tapos ka na, Lance?
Hindi pa, wait lang.
Hello everyone, my name is Andrei Sombillo, and this is my video presentation about our presentation in a parent subject. Our topic for today is test benches in HDL, and the first thing that I would like to discuss would be generating manual stimulus. When we say manual stimulus, it is a way or it is a process on inserting new values to some of data inputs that you have inserted in your test bench manual. So in this video, I'm going to show you how to apply this thing in a simple combinational logic circuit. And since we are only focusing on a test bench module, I already have created a design module in advance so that we could save up some time, and so that this video is a little bit short and it won't take long. So I have created a equation that we were going to solve, which is the, as you can see, the comment above, the y that is equals to a prime b prime that is multiplied into c plus ad and plus ab prime c. So into our design module, I have instantiated parameters with 4 inputs, which is the a, b, c, and d, and 1 output, which is y. I also wired different types of letters over here, which is the f, e, f, g, h, I, and j, which we're going to call them as nodes. And before we begin into our coding session, I would like to show you my truth table and then our logic circuit schematics that I have constructed earlier. My truth table shows the signals that should our design module should have at the end of our program. I'm going to show an EP wave signal as an output so that we could refer to this kind of thing. And then I also have constructed a logic circuit schematic to visually interpret what does this equation have. And as you can see, we all have some letters in here, which is, these are the nodes that I'm talking about. The E, F, G, H, I, J, and then the Y itself, which is the output of our equation. Wherein in this logic circuits schematic, we have used different types of logical gates, which is we have AND, the NAND, and then the NOT gate. So this is a simple combinational circuit that we're going to use anyway. So let's go by creating our module in test bench. So our module in test bench is, I'm going to call it tb underscore dsclc with parameters of registers of E, B, C, and then D, and then wire Y. And then the next thing that we need to do is to instantiate our design module into this thing by just calling the design module name that we have created, which is ds underscore clc. I'm going to name it as A1 and input some parameters in it, which is that A, that B, that's B, and then that C of C, and then that D or D, and D, and Y, that Y, and Y. So upon instantiating our design module into our test bench, this is where we're going to insert some values into our inputs, and this is where the manual stimulus comes in. Sorry for the interruption. I'm back. So the next thing that we need to do, just like what I said earlier, is that the next thing that we need to do is to insert some values into our registered inputs, which is the A, B, C, and D. This is how you do it, which is we should initialize the data and then call them, which is A that is equals to 0, B is equals to 0, and then C is equals to 0, D is equals to 0. Now there are a lot of ways to do this thing, but this is how I'm going to do this. So I'm going to do this 16 more times. 3. Did I really count it? Oh! I forgot about this. I got confused over there. So I'm sorry about that delay. Anyway, so this is how we do it, and then we just end the initial this one, and then we're going to start another one, which is initial begin, and this is where we're going to create a block to output our program, which is dump file from, I think it's test.vcd, and then dump bars 0, going to do this thing 60 times because we have 16, and then we're just going to end this thing as well and end the module. And if I believe so, we could just save this thing. Wait, let me indicate the, oh wait, okay, so in those simulators we have the cursor log. Let me just put the output file name here, which is test.vcd, and then save. Wait, I'm sorry, I'm back. May mga nangangaroling lang. Sorry for the interruption. So I just run my program and it seems like there's a problem. I already know what it is. I forgot to add a function over here which is finishes the program. And if we save that thing and then just run it, I think it would be fine. I hope. There you go. So we have the EP wave, and let's get the signals from E1, and then let's just append them all. And as you can see, this is the output of our test bench. This is the output of our design module that we have created, the design that we have created. And to say that if it's right, we could refer to our truth table in here. In our Y, just like in our Y, we have 0, 0, 1, 1. 00110110110000, which is in our truth table. Our y is 00110011110000. I think I forgot one over here earlier, so I'm sorry about that. But hey, this is our it, it means that our design module that we have created is working fine. That's all for now. Thank you for and have a nice day.
So, ayun.
So
Ah, tapos na si Lance, am I right?
Yun.
So, next reporter is me. I'm papakilala ulit. I'm Jeremy Pierre Tecson. So, my topic, let me share my screen po. So, kita naman po ba yung share screen ko po? So, let me ulit. So, good morning everyone. My topic is all about uh, printing results and sequential logic test benches. So, let's start. So, testing is an important aspect of digital circuit design because it ensures that the design circuits meet the specified requirements and function properly under various conditions. It is critical for detecting and correcting mistakes, verifying functionality, and assuring the reliability and performance of digital circuits. And the testing process assists designers in identifying concerns early in the development cycle, decreasing the likelihood of costly errors and ensuring the final product fulfills quality standards. So sa madaling salita, ang testing ay yung pag-check ng iyong design para katulad ng sinabi dito, para hindi maging magastos in the later stages of your project. So the importance of testing in digital circuit design. First is the error detection. It assists in identifying and correcting flaws early in the design phase. Second is the verification of functionality. It verifies that the digital circuit functions as expected. Third is the reliability assurance. Designers can ensure the dependability of digital circuits. Four is the performance validation. It helps designers to test the performance of digital circuits under various settings. Fifth is the compliance with standards. To assure compliance with certain standards which promote interop- interoperability and safety. And lastly, the cost reduction. Detecting and fixing flaws early in the design process is less expensive. So, printing results of a test bench. So, a test bench is a simulation environment in digital circuit design that allows designers to check the functionality of their circuits. Printing data after creating a test bench and running simulations is a popular procedure for examining the performance and behavior of the circuit. Capturing and displaying crucial simulation findings such as input values, expected and actual output values, and any pertinent diagnostic information is required. So here's an example of a test bench. Uh, this is a OR gate test bench. So let's discuss the code. So the OR gate test bench or the TB OR gate is represented in this module, and the regulator variables AA and BB are the inputs while the wire variable CC is the output. So the CC, AA, and BB are connected to the OR gate module, which is instantiated as O1. And the input values AA and BB are set to a variety of combinations or 0, 1 in the first block with a number 1 delay in between. So yung saan nagbase yung mga values ng AA and BB, binase ito sa truth table ng isang OR gate with 2 inputs. So before ending, the simulation runs for 6 time units. And yung mga dump file and dump bars is magpapakita lang ito ng output waveform. So methods for printing results. First is the display statements. So display statements are used in hardware description languages or HDLs such as Verilog or VHDL to publish information to the simulation console during simulation. Designers can carefully employ these statements to produce crucial signals, variables, or messages. And the second is the waveform viewer. So waveform viewers are frequently included in simulation tools to let users visualize the behavior of signal over time, and waveforms can be inspected by designers to find differences between expected and actual results. So let's compare the two. So this is a example of a display statement, and this is an example of a waveform viewer. So next, let's talk about creating a test bench for sequential logic. So a sequential logic circuit is made up of devices like flip-flops and registers, and its behavior is determined not only by the present inputs but also by prior states. Developing a test bench for such circuits entails creating a simulation environment that generates a series of input stimuli and records the related output responses. So here's an example of a sequential logic test bench. So let's discuss it. So the test bench module creates the D flip-flop, gives the input CLK, reset, and D, and monitors the output Q. So a clock or CLK with a period of 10 time units is created, and a reset signal is first asserted for 10 time units. The test scenario employs a series of inputs including a reset and data input or D changes. And the $display command is used to display the simulation results, which indicate the time inputs and outputs on each rising edge of the clock. So, yun lang po. Kung gusto niyo pong makita yung mga design SV ng dalawang example ko, ibibigay ko po siya sa YouTube link ng code simulation ko. So, yun lang po. So, our next reporter is Yohanne Suba po. So, you can take the floor po.
Hello, kita na ba yung presentation?
Yes, Kitan.
Clear naman yung boss ko.
Okay.
Good morning, everyone. I am Yohanne Angelo Suba, and for today, I will be discussing printing test bench results and using loops to generate. So, first of all, what is test bench in HDL? Test bench is a hardware description language. It's a environment used to verify the functionality of a digital circuit design before it is implemented in hardware. The primary purpose of a test bench is to apply input stimuli to the design under test and observe its behavior, output behavior. Understanding how to print and interpret the results of a test bench for a sequential logic circuit hardware description language is crucial for several reasons. First reason is verification and validation. Test benches are used to verify and validate the functionality of a of digital circuit. Debugging. When designing complex digital circuits, errors and bugs are inevitable. The ability to print and interpret test bench results allows you to identify and locate issues in your design. So yun nga, parang kailangan din natin ng validation and verification para magawa tayo ng uh, proper test benches and yun nga, tapos debugging, di naman nawawala yung pag-debug natin lagi sa computer engineer. Lagi natin ginagawa yan. Performance analysis. Understanding the test bench result can provide insights into the performance of a sequential logic circuit. Functional, functional, functional coverage. Test benches help you achieve a high level of functional coverage by providing a variety of input scenarios and checking the corresponding outputs. You can ensure that your sequential logic circuit has been thoroughly tested for different conditions, increasing confidence in its correctness. Documentation. Test benches serve as documentation for your design. They provide a clear and structured way to understand how the circuit should behave under various conditions. So yun nga, performance analysis na nakikita natin kung paano yung performance ng ating test bench, functional functional coverage. Uh, Dito natin nakikita yung kung tama ba yung nasa code, ganyan, nasa test bench natin. So, and syempre, documentation. So, ito yung example ng test bench sequential logic circuit. Yung design, test bench, at saka yung waveform. Using loops to generate stimulus naman. Verilog system, Verilog system has limited support for this procedural loops in simulation, and they cannot be used in the same way as loops in a software programming language. However, you can achieve similar effects using constructs like for, while, and repeat within initial and always blocks. Using loops in test benches can be beneficial for several reasons. First is automation. Loops allows you to automate the generation of stimulus patterns, making it easier to write concise and efficient test benches. Second is scalability. When you need to test your design with a variety of input values or conditions, loops provide a scalable solution. Readability and maintainability. This test benches with loops tend to be more readable and maintainable. Automation siya kasi yun nga parang nakakagawa tayo ng bagong nakapag-explore tayo ng bagong ano through looping, magiging efficient pa yung paggawa natin. Scalability, nagpo-provide siya ng scalable solution so parang versatile tayo lagi. And readability and maintainability. Ayun, here's an example to illustrate the advantages. So ito, yung advantage ng may loop. Next is ways to use loop for efficient test benches. The first one is loop for clock generation. This loop generates a clock signal with a period of 5 time units. For your example ng code, second one is loop for input stimulus generation. This loop generates different input values specified number of iterations. Third one is loop for testing different scenarios. This loop allows testing different scenarios by changing input values based on the loop index. Fourth one is loop for random stimulus generation. This loop generates random input values for a specified number of iterations. Last way is loop for varying delays. This loop varies the delay between the operations to test different timing scenarios. So marami pang ways para gamitin yung loop sa test benches. Ito lang yung mga nilagay ko. So, yun lang po sa akin. Thank you. Bibigay ko naman po yung floor kay Daryl at Severino.
So, good morning, everyone. So, my topic one is automatic result checking. So, for automatic result checking, an automatic result checking is a technique used in simulation and testing to verify whether the simulated results match the expected or golden reference values. This process is particularly useful in verifying the correctness of digital designs or algorithms during development and testing phases. By automating the result checking, you can quickly identify these discrepancies and potential errors in the simulation output. The goal is to automatically verify that the simulated results match the expected values for each test case. So, the always block is sensitive to changes in signals A, B, and C. So, the if statement checks whether the current value of CC matches the expected value of the A and B. If not, it enters the if block. So, just like here. So, if CC is not equal to A and B, then it will then go to the display and then echo the test failed message. So this is the result. So in the event of a failed test case, an error message is displayed providing details about the input A and B and the observed output C. Additionally, it indicates the expected output based on the logical AND operation. So this is a AND gate, and then since A and B is equal to 1, so C should also be equal to 1. But then it encounters an unexpected value, which is 0. So that's why it echoes the message test failed, and then it also indicates the expected value, which is 1, which you can see in the close and open parentheses, which is the expected 1. So this approach automates the result checking process during simulation. If any test case deviates from the expected behavior, the simulation will be halted and an informative error message will be displayed, aiding in the identification and correctness of issues in the design or test bench. So the second topic is the using an external file in test bench. So this initial block uses the read mem system thus to read the contents of the external file expected underscore results dot text into the expected results array. So in this code, the read mem gets the external file, which is the expected underscore result dot text, and then puts it inside the expected underscore results. So it compares the expected result from an external file with the actual result generated during the simulation. So this block of code compares the file to see if the external file is used. So if the expected underscore result is equal to the A and B, and then it will display the message external file is used. So this code segment checks whether the actual result generated by the simulation A and B matches the expected result for the first test case. If there is a mismatch, it prints the message external file is used. So here is the output. So since there is a mismatch in the code, the expected underscore result is not equal to the A and B, so then it prints that the external file is used. The code segment checks whether the actual result generated by the simulation A and B matches the expected result for the first test case. If there is a mismatch, it prints the message external file is used. So for the third topic is the generating output waveform using test bench. So this Verilog code is part of a test bench, a simulation environment used to verify the functionality of a digital design. It configures the simulator to generate a VCD file named test.vcd and records the values of all variables during the simulation. The simulation will run for a duration of 6 time units and then terminate. So this is the first topic that was discussed in our subject. So this is the first method for displaying or generating output waveforms. And the second one is this, using the display. As you can see, the display is repeated 4 times. And there is another way to code this, which will be much better than displaying it 4 times. It will only be displayed 1 time. So the display statements are used to print the values of A, B, and C at different simulation times. This way, you can observe the waveform in the simulation console itself without the need for a VCD file. Adjust the format specifying the display statement based on your preference. So here is the output. At time 1, A is equal to 0, B is equal to 0, then C is equal to 0 since it is an AND gate. So in time 2, if A is equal to 1 and B is equal to 1, then C is equals to 0. Because an AND gate will only be 1 if all the inputs are 1. So at time 3, if A is equal to 1, then B is equal to 0, then C is equals to 1. Then at time 4, both A and B are equal to 1. That is why the C is equal to 1. So here is the other way of displaying the simulation console without the need for a VCD file. So instead of using the display, you can instead of using display and repeating it 4 times, you can instead use monitor. So the monitor system task is used to print formatted text to the simulation console whenever the specified signal changes their values. In this case, it prints a message containing the simulation time and the values of signals A, B, and C whenever there is a change in any of the signals. So basically, the monitor displays a signal whenever a value changes. So it will only display a signal if the value is changed. So just like here in the output, signal the signal A 0, signal B 0, and then the output is 0. So the second one is signal A 0, signal B is equal to 1. The signal change, that is why the monitor is used. So for the third one, A is equal to 1, then signal B is equal to 0, then signal C is equal to 0. Then for the last signal, A is equals to 1, signal B is equals to 1, then signal C is equals to 0. So that concludes our topic for this subject. So thank you for listening.
So that will be the end of our reporting. So please open your cam again for the second attendance po. So ano na, give your best smile again po. So 1, 2, 3, smile. So ayun na po. That will be the end of our meeting today. So good day po everyone.